All right, so welcome back, my calc students. We are in Chapter 3, Section 3. The topic is on what we call the first derivative test. But where we're going to begin is going to seem somewhat intuitive, or maybe simple enough that we need not even spend a lot of time discussing it. So, for example, if I were to ask you, how do you know when something is increasing or decreasing? And as I said, it's quite an intuitive concept, but to a mathematician, to mathematics, there's a certain level of exactness a certain level of preciseness that we need in our definitions. So we cannot be sloppy. We cannot be sloppy in our words. So let me see if I can offer an explanation of what it means to say a function is increasing or decreasing formally. Okay? So I'm going to read the definition, but before I read the definition, let's take a look at the graph that I've produced for you, right? So we just have some parabolic, some quadratic that's graphed. And notice that I've labeled two of the x values, all right? So x sub 1 and x sub 2. Now, let me start. So it says a function f is increasing on an interval when, for any two numbers, x sub 1 and x sub 2 in the interval, x sub 1 less than x sub 2 would imply or implies that f of x sub 1 is less than f of x sub 2. Now, what are these mathematicians trying to say? So you and I agree that, so I have 2 points, 2 x values, x sub 1 and x sub 2, and I think you would agree with me that in this case, x sub 1 is less than x sub 2, and in fact, we would be proceeding from x sub 1 to x sub 2, okay? Now, let me go ahead and plot f of x sub 1 and f of x sub 2. So if I take this point and I were to substitute it into whatever function this is, this would be f of x sub 1. Likewise, if I were to take this second point and plug it in to this function, this would be f of x sub 2. All right. And now, notice what the definition says. For any two numbers, x sub 1, x sub 2, in the interval from x sub 1 less than x sub 2 would imply that f of x sub 1 is less than f of x sub 2. That means, look, for any two numbers that you choose, as long as x sub 1 is less than x sub 2, then f of x sub 1 will be less than f of x sub 2. Does that make sense? Notice, let's get rid of the f notation, right? Let's just say y. Don't you agree with me that y sub 1 is less than y sub 2? Right? And that as long as my x sub 1 is less than my x sub 2. Then in that case, what we get to say is we get to formally state that under those conditions, your function is increasing, right? We are increasing over that interval. All right, now I will spare you the lecture on decreasing, but it's the same idea, right? It's just an implication. Now for every x1 you choose, you're going to have a y value that's less than the previous y value. Okay, that would be the definition of decreasing. Now, the definition of constant, now that's not written here, but that's fairly easy to see that when a function is constant, it would have, obviously, the same y value. I think that makes sense. All right. With that in our tool bag, at least now we formally can state what is increasing or decreasing. What is this section all about? What do they want from us? So let's start. So we're going to take a look at this first figure, all right? So Again, I've marked off 2 points on my x-axis, but instead of using this subscript notation, let's just call it A and B. Ready? Let's, you and I, just visually look at this graph and say where the function is decreasing. All right, so I think you're going to agree with me that from negative infinity all the way till you get to point A, you are walking downhill, you are decreasing. Okay, now, once you get to point A and you proceed to point B, notice that the graph is constant throughout. From A to B is constant. Once you get to point B, you are walking uphill, you are increasing from B to infinity. Okay, so fairly easy. But what this section is going to show you is the derivative itself can give you all of this information. Right? Let me see if you can follow me. If I give you a slope that is negative, say negative, let's make up something, negative 1/3. Well, doesn't a negative slope, a negative rate of change, doesn't that imply that you would be decreasing, right? Likewise, if I gave you a positive slope of 1/3, the positive nature of the slope would imply that you are increasing, that you are walking uphill. And in fact, what if the slope was 0, right? You have 0 rate of change. In other words, you would be constant. You would be the graph would be constant, or the ground would be completely level with the horizon. So in each of these cases, if I just gave you the slope, well, then I think you would be able to make a statement about whether the function is decreasing, increasing, or constant. But isn't that what the derivative does, right? I mean, think about it. The f prime of x, what is it? The derivative, what does it do? Well, it's a function, right? I mean, a function is a machine, and you have to give it an input. And when you give it an input, it will give you back out an output, something that you wanted. But what does this derivative machine give us? Well, if you give it an x value, that's your input, it will give you back out a slope. So, as I said, the derivative itself, it contains all the information that you're going to need to be able to make statements about increasing or decreasing. Now, that's increasing or decreasing at a single point. What if you want to talk about increasing or decreasing over the entire graph? Well, the derivative is going to play a role for sure, but we need a little bit more work in order to talk about where it's increasing or decreasing through the entire graph. Okay, no more theory. Let's jump in. So the question reads as follows. We're asked to find the intervals, right? The open intervals for which this function x cubed minus 3/2 x squared is increasing or decreasing. They don't want just a single point. They want to know the entire interval or intervals where it's increasing or decreasing. Okay. Now, we're somewhat spoiled here because I've already given you the graph, right? So what I need from you is I need you to for right now, let's pretend like this graph and this answer is not just blatantly staring us in the face. Let's actually walk through the work that would be required. Okay? So I'm going to give you a playbook. I'm going to give you some step-by-steps to help get you there. So let's start with the first step. Now, the first step is going to be to find the derivative of f. Okay, now I'm not going to walk through the steps of how to do the derivatives. That was the entire point of chapter 2. So I'm going to assume f prime of x. I'm about to write the derivative, and I'm going to assume that you would be able to follow me through to get to this derivative. All right, ready? So the derivative is 3x squared minus, well, 2 times 3 halves is 3, so minus 3x. Okay, so that's your derivative, but what do we want our derivative to do for us? So step 2 in this process is going to be to use the derivative to find the critical numbers. All right, to find now, if you recall from the previous videos, just in case you have forgotten, the way we define a critical number is the x values where your derivative is either equal to 0 or your derivative is undefined, meaning it does not exist. Okay, so both of these conditions would produce critical numbers. Let's start with the second, because we're actually going to be able to rule out the second. So now, a derivative would not exist in a scenario where you're trying to divide by 0, correct? Or if you were trying to take the square root or the even indexed root of a negative number. Now, I don't have any square roots or even roots radicals in this function, nor do I have a fraction, so we don't have to worry about either. So let's instead focus on when the derivative would equal 0. So what am I going to do right now? I'm going to take f prime of x, which was equal to 3x squared minus 3x. I'm going to take this and I'm going to set it equal to 0. Okay. So your goal is, let's see if we can factor it, right? Let's see if we can turn this subtraction problem into a product. So we're going to factor out a 3, and we're actually going to factor out an x as well. So we'll factor out a 3x, and let's see what's left. All right, well, if you factor out, now remember to factor out means to divide out. So if you factor out a 3x from a 3x squared, you would just have an x. And if you factor out a 3x from a negative 3x, you would have negative 1. Okay, you could always redistribute to make sure you did the factoring correctly, but at this stage, we're on to something, right? So now we have two factors, two parts, and we want to figure out how, if we can make one part or one factor equal 0, then we would make everything equal 0, right? That's the beauty of a factored form. If a times b equals 0, if a equals 0, then b must automatically equal 0, and likewise, vice versa. So how would you make 3x equal 0? Well, there is only one way to make 3x equal 0, and that's if you chose 0 for x. How would you make x minus 1 equal 0? Well, there is only one way to make x minus 1 equal 0, and that's if you were to choose 1 for x. Okay, so do you agree with me that we have found our critical numbers? Our critical numbers are 0 and 1. So now what are we going to do? So let me go to step 3. So what I would suggest is that you use the critical numbers. Let me write, and then I'll draw exactly what I'm saying. Ready? So we're going to use the critical numbers to subdivide the number line. All right, now what do I mean by subdivide the number line? Ready? So let me just draw a number line. So here we go. Here is all the numbers from negative infinity to positive infinity. Okay, now I'm just going to go ahead and put a 0 right here. And what I'm going to do is I'm going to place each critical number on this number line. Okay, so 0 was one of the critical numbers, and the other critical number was 1. So I'm going to put a 0 here, and I'm going to put a 1 here. Now, notice what this does for us. So let's imagine that you had a piece of string, right? A long piece of string. And I gave you a pair of scissors and you made 2 cuts on that string, right? You had a long piece of string, you made a cut at 0, and then you made another cut at 1. How many pieces of string would you have? Right, you would have 3 pieces at that point. You would have a piece from negative infinity all the way to 0. Then you'd have a piece from 0 to 1. And then you would have a piece from 1 to infinity. This is what I mean by subdivide our number line. All right, so now let's not lose sight of the question. The question was, where is the function increasing or decreasing? So the game that we're going to play, the way this is going to work, is we are going to choose a number. Doesn't matter which number, okay? Any number that is in the intervals that we just wrote down. And we're going to test to see if that number produces a positive slope or a negative slope, okay? And then we'll make a statement. Ready? Let's actually... So the way I'm going to do this for you, you can do this the same way if you set it up on your quizzes and your tests. But so we start with our intervals. Now we need a test point. Okay, ready? Let's pick any point that is in this interval. So I'm going to choose -1 because -1 is in the interval negative infinity to 0. I just need you to understand that if you would have chosen 2, -2, everything would have been fine, right? As long as you are in the interval. All right, so now I need to choose a number between 0 and 1. I'm going to choose a half. And then I'm going to choose a number from 1 to infinity, and I'm just going to choose 2. All right, so make life easy on yourself. Just choose easy numbers to work with. Now what are we going to do with these test points? Well, you are going to plug each test point into your derivative. Ready? So let's go ahead and do that. So I'm going to, for this first example, I'm going to work it out for you. Ready? So this would be f prime of what? What are you actually plugging in? You're plugging in -1. Ready? Let's see what the math looks like. So this would be 3 multiplied by -1 to the power of 2 minus 3 multiplied by -1. Okay. Now, so if you can let your calculator do this arithmetic for you, or you can run through it in your head. It's fairly simple. -1 squared times 3 minus 3 times -1, and you should get the positive number 6. Okay, now I'll come back to what does that mean in just a second. Ready? Let's go through the next 2. So we're going to need to plug in f prime of 1/2. We're going to need to plug in f prime of 2. All right, ready? It's the same idea. You're plugging in 1/2, you're plugging in 2. So this would be 3 multiplied by 1/2 to the squared minus 3 multiplied by 1/2. And what do we get? Well, you would get -3/4, right? -3/4. And finally, if you plug in 2, this would be 3 multiplied by 2 to the power of 2 minus 3 times 2. All right, and what would you get? If you plug in 2 into our derivative, you would get 6. Okay, now if we assume, I'm going to assume that my arithmetic is correct, although my wife will tell you that I I never make mistakes. It is not true. I do make mistakes sometimes. So, assuming that my arithmetic is correct, let's actually answer the question. Ready? So, a positive 6, that would mean the slope is positive. M, right? The derivative produces slopes. This is a positive derivative. Let's make the statement that the function should be increasing. All right. Now, negative 3/4, that's a negative slope. So the first derivative lets us make the statement that the function should be decreasing over that interval. And finally, again, another positive number, a positive slope. So that tells us that the function should be increasing over that interval. Okay? So, and now let's look at the graph. So do you notice how, let's start with negative infinity to 0, right? Let's start here. So notice from negative infinity all the way till you get to 0, notice how your function is increasing the whole way. And then as soon as you get to 0, as you proceed from 0, we had a negative slope, which means that our function is decreasing from 0 all the way to x is 1. Once we get to x is 1, a positive slope tells us that our function is starting to increase again, and it continues. So that last part is that last part of that problem where you say it's increasing or decreasing is the most important part, right? Don't leave that part out, because otherwise it's it's like you're never drawing a conclusion. You're talking, but you're not ever drawing a conclusion on from the work that you're showing. So that last part is the most important part. All right, and where do we go from here? So I'm going to take a break. We're going to come back. The next video, we're going to continue with using the derivative. Only now we're actually going to let the derivative do a little bit more for us. So instead of just telling us where your function's increasing or decreasing, we're actually going to be able to use the derivative to figure out where the relative minima or maxima is. I will see you there.